Hello scholars, welcome. Mr. Hinkle here. In today's lecture, we are looking at the Earth system, Earth as a system, and understanding the complexity and the interrelation of all of Earth's individual parts. Let's get into it. We will discuss systems in terms of thinking and science, because this is a science lecture, and we will define the Earth system and analyze its interacting parts known as spheres. So we'll start here. What is a system? The solar system, the human body, the university, the education system, your job, your family is a system. A set of interacting parts that function as a whole, and of course, the Earth system, which is the focus of our lecture. It operates according to specific rules and principles, and there are interactions with systems that govern its behaviors, its inputs, its outputs, and its responses to external forcing events. Please see Earth system interactions if you're like, ooh, tell me about those interactions. I'm interested. A systems approach is holistic. Traditional thinking is A causes B to happen. Systems thinking says, well, for A to occur, you have B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, and they're all creating inputs, and there's intermediate pathways. We can map these out in a causal loop diagram. Systems thinking is really useful for understanding the human component to set how society functions, and also for thinking about the Earth, because the Earth is so complex and it works as a system. It does not work in isolation. The Earth system refers to the interconnected processes that are happening through physical, chemical, biological, and geological levels. It encompasses all of the Earth's spheres and the interactions among them. So if a system is a set of interacting parts that form a whole, the Earth system's interacting parts are called Earth's spheres. So let's start to write this here. I'm going to come back to this actually. Earth system science is a holistic study looking at the complex interactions and processes addressing Earth's various subsystems and how they form a single integrated system. So where did it go here? All right. The sun, the primary driver source of energy for all life on Earth, creates temperature differences on land and water, creating weather. Volcanoes erupt aerosols into the atmosphere. Temperature differences lead to ice, which can affect Earth's temperature. Humans are a big component, affect land use changes. The land on its own has various types of vegetation and species that are on here. And so there's a lot going on the surface of the Earth. And it's really hard to think about all of these all at once. But when we can look at subsystems and then place them in the context of the greater Earth system, we start to get that systems level understanding how an effect in one part of our Earth can impact other parts of our Earth. It is all related. We are all connected. Let's see, got that over there. Another key thing to note is that we have our Earth systems. I feel like I need to start writing some things down. This board just feels so blank and lonely. What moves through the Earth system? The recycling of matter and the flow of energy. These two entities also happen in complex pathways. And where do they move through? You guessed it, through Earth's spheres. So, energy, matter are traveling through the air, the water, the life, the rocks, the ice, through people, and this is the discussion for our subsystems of the Earth system. The short list is here: the exosphere, space, geosphere, rock, atmosphere, gas, hydrosphere, liquid, cryosphere, ice, biosphere, life; anthroposphere, humans. Now, we could think of this as being 1, 2, 3, 4, where we've got life, rock, air, and water. But Earth system science has an even more comprehensive, detailed view looking at Earth spheres, where we're bringing in all, is the 7, 2, 4, 6, 7 of these. So let's go through these one at a time. The exosphere. And this is space. What we get from space, well, our only star that provides light or heat energy to our planet, the sun, which is the primary source of energy for all the spheres, exists. So we want to think about everything that's impacting Earth. The sun provides a very large impact to our planet. The solar radiation is critical for life on Earth as we know it, for weather in the atmosphere, for the movement of water. The sun is necessary and hostile to life, so it is very important. Let's keep going. The geosphere, aka the lithosphere. Geo means earth, litho means rock, is the solid environment or all the rocks on Earth. And the creation, the transformation, the recycling, and the destruction of Earth materials, of rocks and minerals, is known as the rock cycle. The geosphere produces its own energy. The rock cycle, Earth's internal energy drives plate tectonics, which give us different types of rocks at Earth's surface, giving us land and ocean. Have you ever wondered why continents stick above sea level and there's ocean bottoms are so far below sea level? Well, it has to do with the processes of plate tectonics and the partial melting of rocks in the rock cycle, but I'll save the geology lecture. The solid Earth is the geosphere. The atmosphere, the thin veneer of gas that surrounds our planet, which is important for so much. It's where weather occurs. It has particles that block out harmful UV radiation that protect life on our planet. Very, very important. Traps Earth's heat, giving us a regulated climate known as the greenhouse effect. So lots of things happening in the atmosphere, very important. The hydrosphere. We know this as the water cycle, the movement of Earth's water on Earth, from the oceans to the atmosphere to land. I'm made of water, you're made of water, all life is made of water. The movement of water in ocean currents, which is wildly important for the transportation of heat. That way it's not so hot at the equator and so cold at the poles, but the redistribution of heat energy through oceanic circulation patterns. You could consider the cryosphere to be part of the hydrosphere, but the way we're looking at it here is liquid and ice. And this is because ice plays such an important role in global climate. When there's a lot of ice, it reflects a lot of Earth's solar energy, meaning that temperatures are cooler. And when there's no ice, Earth's albedo decreases, which means that temperatures are hotter. And so temperature and the amount of ice on Earth's surface are intricately related. The biosphere, all life on Earth is considered the biosphere. And life is unique on our planet, maybe? We're rewriting the history books about this one. But life is really important for regulating global climate through reducing greenhouse gases, the uptake of carbon in the atmosphere by marine organisms helps to keep air chemistry that is relatively stable, water chemistry that is also relatively stable. So already you're seeing it's really hard for me to talk about one without talking about the others. And that's due to these Earth system interactions. Humans, here's the Earth at night. We have electrified our world. We have changed the surface of the Earth. We are altering the amount of greenhouse gases we do a lot to our environment. We are not the only species on Earth to alter their environment. Think about beavers. They create these big beaver dams. They back up the water so that they can have homes. Or ants dig lots of tunnels. They have big ant mounds. So species change their environment. But humans have changed it a significant amount that we could be considered one independent subsystem that has effects in the rest of the greater Earth system. So these are the spheres of the Earth system. We're thinking about Earth holistically as a set of interacting parts that all affect each other. Now, when we study Earth, when we study science, when we study physical processes, we're looking at really isolating how a process works, but then adding that into the discussion so that we can get to how does our Earth system function as a whole. The spheres interact with each other through forcings, feedbacks, sinks, and tipping points, and they are also where matter and energy is stored, called sinks, for various periods of time, called residence time. These are the important components to think about when understanding, learning, reflecting, getting to know our Earth system. Thank you so much, and I will see you again.